I'm Mark Achtman. I'm principal investigator of the Science Foundation of Ireland and a professor in microbiology at University College Cork. We've achieved a historical reconstruction of the transmission routes of plague over the last 1,000 years and more by looking at the genetic diversity and properties of Yersinia pestis from around the world. This work continued our work that we did previously at the Max Planck Institute for Infectious Biology in Berlin, and the first author of our publication, Giovanna Morelli, is still at the Max Planck in Germany. Plague is endemic in rodents throughout Eastern and Central Asia. So large parts of China and the former Soviet Union have plague foci in their rodents and occasional infection of humans. Plague is endemic in large parts of Central and East Africa. In fact, just a few months ago, there was an outbreak of pneumonic plague in a mine in Congo, which led to such panic that people scattered immediately. Plague is endemic in the USA. It was imported in 1899 and has spread throughout the western United States. The number of human cases is quite low, but just 2 weeks ago, there were 5 cases of pneumonic plague in Tibet, which led to quite a bit of concern. What it's shown us, firstly, is that it is possible under special conditions to reconstruct history from genetics for an epidemic bacterium, which has not been done at this level before. It showed us that you can use genomic information to reconstruct routes of spread on bacteria, and it's allowed us to tie in historical records to modern genetic insights. The bacterium evolved or originated in China or the vicinity. That is quite clear. It's spread from China on multiple occasions. We see plague spreading to former Kurdistan, which would now be parts of Turkey, Iran, and Iraq, via the Silk Road, which existed for almost 2,000 years. We see plague arriving in Africa about the time, a little bit before the time of Columbus, probably accompanying Chinese voyages, enormous voyages, and possibly in greatest detail, we tracked the various routes of spread of the last pandemic, which was exported from Hong Kong in 1894. And we see that going to India, we see it going to Madagascar, we see it going to the US, to Africa, to all over the world. And each of those routes is now shown by the genetic information. We think we can understand which of these bacterial groupings were responsible for which of these pandemic events. The one that we're missing is Justinian's plague, which led to the fall of the Roman Empire, and we're not sure about that one, but we think we have most of the others now. There's actually a second publication that came out a few weeks ago by colleagues of mine in Germany, Barbara Bramanti, and she has used ancient DNA analyses to look at skeletons from plague pits all over Europe, and has been able to show that these were associated with these bacteria, Yersinia pestis, and has found particular genetic groupings from those skeletons, which map onto our new discoveries as well. So we're now, for the first time, fairly confident that the bubonic plague and the Black Death was caused by Yersinia pestis, and we know roughly which genetic groupings were causing that.